Hi guys, welcome back to another low quality math video. Today we're going to be going over our final concept on three-dimensional areas, which is cones, specifically right cones. And if you remember right cylinders, which were cylinders that had perpendicular axes, then this is going to be similar to that. So a cone is basically like a pyramid, except instead of a polygonal base, it has a circular base. Like a pyramid, it also has one vertex, and it has a lateral surface that connects the circle base to the vertex. And I forgot to mention this on the cylinders video, but cylinders and cones have axes. On a cylinder, then the axis would be the segment that connects the centers of the circles. On a cone, the axis connects the center of the circle to the vertex. So right here, this segment right here would be the axis. And like how in order for a cylinder to be right, then the axis has to be perpendicular to both of the bases, on a right cone, the axis has to be perpendicular to the base. So it has to be the altitude as well. So if you remember from pyramids, then the altitude was basically the segment that contained the vertex and was perpendicular to the base, and the altitude on a cone is exactly the same. It contains the vertex and it's perpendicular to the base. And in order for a cone to be right, then the axis, which contains the center of the circle as well as the vertex, has to be the same segment as the altitude. So in order for a cone to be right, it has to have a segment that connects the vertex and the center of the circle and is also perpendicular to the circle. So let's go into some of the formulas for a cone. So first, let's go over a few of the dimensions of a cone. We already know what the radius is. It's the radius of the base, since the base is a circle. We have an altitude. The length of the altitude is called the height. And we also have a slant height. Like pyramids, the slant height is basically the distance from the vertex to the edge, except on a cone, it's the distance from the vertex to the edge of the circle. So this would be the slant height. And in order to find the lateral area of a cone, the formula is pi times the radius times the slant height. And I'll explain why this is. So you can think of this as two ways. You can think of a cone as basically a pyramid with an infinite number of sides. Since a circle has an infinite number of points, you could draw lines like this and say that any two of these were sides. So I could draw a line right here and a line right here, and I could say that this was a side. I could draw a line in between them and say that these are two sides. Since there's an infinite number of points, then a cone has an infinite number of sides. You could think of it that way. And since the lateral area of a pyramid is 1/2 times perimeter times slant height, then you could say that the perimeter of a circle is the circumference, and then you would end up deriving pi RL if you simplified it all the way, since the circumference is 2 pi r and these would cancel out. You could also think of it another way, with the lateral area being a sector of a circle. So I made another model of a cone this time, and once again the lateral area is blue and the base is red. And so this is a cone. So if I were to cut this open, you can see that the lateral area, here I'll put a white piece of paper so that's much easier to see. You can see that the lateral area is basically a sector of a circle, and that the base is a circle as well. So since when you fold it together and curve the lateral area around, the edge of the lateral area goes all the way around the circumference of the circle like this, then this means that the arc length of this lateral sector must be equal to the circumference of the base circle. And if I were to separate these two and wrap a piece of string around each of them to measure the length, then you would see that this was true. So let me wrap a piece of string around the length of the lateral sector. So this is the length of string that shows the arc length of the lateral area. And if I were to wrap this around this red circle, then you would find that it fits almost perfectly around. It's not going to be exactly perfect because this is only a rough figure, but it's very close. So you can see that it fits almost perfectly around, like that. So basically what this is proving is that the lateral area is just a sector of a circle with an arc length that is equal to the perimeter of the circle. And since you can find the area of an arc using this formula x, which is the angle measure of the arc, x over 360 times the radius of the full circle, it would go around like this. So the slant height is the radius of the lateral circle. And if you were to work this all out, then you would eventually get pi times r times L. And I did this by substituting x over 360 by 2 pi r over 2 pi L. Since we know that the arc length of this lateral sector is 2 times pi times r, since it would have to wrap all the way around. And if it was complete, then the whole circle circumference would be 2 times pi times L. So this would be the same proportion as if we used angle measures. We just multiply that by the total area, and we find that the area of this sector right here is pi times r times L. And the surface area, we're just adding the lateral area, so pi times r times L, to the area of the circle base, so that would be pi r squared. So that may have been confusing, so just to review, the lateral area of a cone is basically just a sector of a circle that has an arc length that is equal to the circumference of the base. And we can justify this since we know that this arc length right here, the edge, would have to wrap all the way around the edge of the circle. So we know that this length around this sector is equal to the circumference, and we can use the formula to find the area of a sector using this knowledge to find that the area of this lateral sector is pi times r times L. So now let's do a practice problem. So here they give us a diameter of 8 and the height of the cone is 6. So first we have to find the slant height because we know that the lateral area of a cone is pi times the radius times the slant height. We already know what r equals, since it would just be half of 8. But in order to find the slant height, we would need to use the Pythagorean theorem. So I'll just do that right here. And we find that the slant height is 7.21. So we would just multiply that, and we would get that the lateral area is 90.62. And now we just need to add the area of the circle to the lateral area, and we get 140.88 units squared. So this is the total surface area, and this is the total lateral area. So that was cones. The explaining what the lateral area was might have been kind of confusing. So if you don't really care as to why the formula is pi times r times L and you just want to get the final answer, then just memorize the formula. But if you're like me and you're always wondering, well, why is this formula this and why is this formula that, then that explanation was to kind of help you understand. So that was cones. Hope I didn't help.